And thanks for Phil, for Arrows, and for Angelo for giving me the chance to share in the Flowlog. In this lightning talk, I will mainly focus on demonstrating Flowlog in the real-world systems. So I think many people's first question is, what is Datalog? It's totally fine if you do not understand it. On the Wikipedia, the definition of Datalog is a declarative logic programming language. So in my understanding, you have an input, you have rules, you pass the input through the rules and get the output. The output can then feed back into the rules and then derive the new outputs again, and we call that recursion. How a Datalog rule looks like: we have a head and we have a body. The head relation is what we want to derive to, and the body relation is the rules depends on. Let's see some more concrete example. In this rule, we're trying to join the reachable with the load instance field, and then join with the var points to, and then join with the instance field points to. Any tuple that can satisfy this body will derive into the var points to. You've already may notice that the var points to appear in both sides of the rule. It appear in the body, which participates in the join. It also appears in the head, which the new fact is feeding to the var points to. That means any new stuff derived by this round will feed back into the next round and further derive new facts. Such recursion will repeat again until there's no more new data produced. We call it fixed point. This rule is actually coming from a very famous Java points to analysis, which is called dupe. Here is one of the analysis, which is called, maybe too small. It's called context insensitive analysis. Here I add some more declarative about input and output, but you do not need to understand them. They just define whether how to name a relation and how to define the schema. So the full dupe is very large. We implement the dupe using the Flowlog, and you can scan the QR code if you are curious. So we know how to write a Datalog program, and then comes the question, how we running the program. Here is the first demo. It's running the one-shot mode. Here the Flowlog is just behavior like a normal compiler. We use a Datalog program. We point the compiler to the input and the output, and then compile it. And then we can running the generated executable parallelly. So how the Flowlog performs in the real-world systems? Let me show you some figures. Here's the runtime and the peak memory figures. The left side is a Polonius. You may know that Polonius is a Rust borrow checker. I just got a bad news that in this year, Rust is trying to decide to move the Polonius from the Datalog into a more dedicated graph engine. So this is actually called Legends in Polonius. The other is a dupe, where I already said before. When running this two workload, the x-axis is all the input workload. This can be scalable or WGPU or ClapRS, and that's same for the dupe. The top figure is about the running time, and the down figure is about the peak memory. Oh yeah, it's maybe too small. Let's just say the conclusion. Among all the 24 workload, Flowlog is fastest. The median runtime compared with Soufflé were 4.9 faster on Polonius and 3.9 faster on the dupe. Let's also show some scalabilities. On these two workloads, Flowlog performance can scale well through to the 32 threads. And why? Here is some very high brief summary about this different four systems. Of course, there are more Datalog systems, but some are very legacy, like they are no longer maintained, and some system is actually just not open source. I cannot compare. So for the Soufflé, it's the most famous, most mature one-shot toolchain. The shortage of the Soufflé is it uses beach indexes inside, so it limited the jump parallelism to the out loop. The second is ascent. I think there's previous talk here about ascent from the Sequence University, right? I even know the author. So ascent is very elegant. It's a lightweighted embedded in the Rust macros, but that is also a bad news. You have to implement many details by yourself. So a lot of features require your human engineering, and the performance needs hand tuning. Datalog is coming from the VMware. It has incremental execution ability, but it has high memory usage from the duplicated stateful intermediates. And our system, Flowlog, first, it applies a lot of Datalog aware optimization. Second, it have a fine-grained join parallelism. And finally, we also have the incremental execution ability and some richer semantics beyond standard Datalog. So for the incremental, let's see another demo. We want to update a loop as the input changes. So when you want to run in incremental, you just make a new flag to make the compiler know, now I want to run incrementally. After running the executable also parallelly, it will give you an interactive shell. The interactive shell basically has these 4 commands. At the logic timestamp 0, we just load some base facts and run the analysis. The beginning will start a transaction. We load the input from the disk, and then we commit it. So as you can see, this workload is Tomcat, just a workload for the loop. The size of the var.2 is about 5 million tuples. Now, here's the tricky things. At timestamp 1, I want to remove 1 tuple from the input, and I still want to have the output. So a basic naive idea, and most of system doing here is just like running from scratch, but that is very time consuming. So for Flowlog, we begin another transaction. We use a put command to delete 1 tuple from the input. Here the negative one meaning the retraction, and then we commit it. And the Flowlog will tell you, this tuple is deleted from the output by the negative, by the difference is -1. This incremental update will take only about 7 milliseconds, while if you compute from scratch, it will take about 2.23 seconds. In total, it's about 320 times faster. So the previously transactional model is each logic time will accept input changes and then produce corresponding output deltas. So as you can see, we can commit a t-3, and then we commit t-2, and then we commit t-1, and until t. This is powerful, but this have limitation. Just imagine a situation. At logic time t, we suddenly figure out we lost something at t-2. And we still want to insert such changes at logic time t-2. So for here, Flowlog is developing an interesting feature. It's called time travel. Like we can insert any data at any timestamp. Suppose we insert as a t-2, and then the Flowlog system will correspondingly having the new derived t-2 data and corresponding t-1 and until corresponding timestamp t. So this feature, potentially it can support some agentic verification. Is actually there a paper using Flowlog is like submitting. Another is we can support more powerful continuous program analysis and also supporting the policy and provenance. Finally, I want to talk about some extended semantics for Flowlog that is beyond the standard Datalog. I'm not sure if most of you know Datalog, but for standard Datalog, the relation can only increase. The relation can never be retracted, which is a very big limitation for Datalog. So here we introduce a new syntax. First, it's a fixed point. Fixed point means the Flowlog will running the corresponding code blocks repeatedly until there's no more new data, which is very easy to understand. The tricky thing is we can mark some relation as iterative. Then this relation is meaning it can be both added and both retracted. A very classic example is k-core. Given this graph, we are trying to find the result vertices should be at least have 2 neighbors. We can move step by step. At iteration 0, E has only have 1 neighbor, so we delete E. As iteration 2, because E is deleted, so D only have 1 neighbor too, so D is also deleted. And finally, it remains on a triangle, which each vertex at least have 2 neighbors. This is a very typical program that standard Datalog cannot express. Beyond that, we also support some interesting features. We support Flowlog can manually control whether when the iteration or the recursion should stop, or the data can decide it when it is satisfied some if condition, the recursion can stop too. So Flowlog has an online tutorial about docs and a very small playground you can play with Flowlog online. The QR code is here. And Flowlog is an open source project. You can play it on the GitHub, and if you're interested, you can start us. And we have a paper in VODB. This paper is more like focused on how Flowlog system side is designed and like how we like empower the good parallelism and why some features we can support it and other Datalog system cannot. Yeah, thank you. And if you have any questions, I can answer. well.
I mean, what's the like internal unification algorithm? Like, I don't know, you were saying that there's B trees in Souffle.
Yes. The low-level library Flowlog using is actually called timely dataflow. If everyone,
okay.
yes,
Cool.
yeah.
Okay. Sounds good. Thank you, Zhenghong. All right. Before the